Hello everyone, and thanks for joining me. In this video I'm going to look at Q1A. The town of Clareville borrowed $10 million at an interest rate of 4% compounded annually. On the first and third anniversaries of the loan, the town made payments of $4 million on the loan. What payment must be made in the fifth anniversary in order to pay the loan? Okay, so what we have is some basic information that we really need to draw out in some type of timeline. So I'm going to draw a timeline here. I'm going to call this now. Okay? So effectively, what's going on as we move forward is the town has borrowed $10 million. And it does that now. And it's at a 4% compounded annually. Okay. On the first and third anniversary, so year 1 and year 3. Okay, year 1 and year 3, you're going to pay some money back. So we're going to put negative 4 million and negative 4 million. That's what's going on there. And on the 5th anniversary, you're going to pay another amount, 5, and that amount is a mystery. Okay, so effectively what we've got is we got an amount now, a payback in year 1, a payback in year 3, and a payback in year 5. So essentially you could think of this as an amount of money that is accumulating interest as it goes this way. Okay, that amount of money, that $10 million, is accumulating money, accumulating interest expense as it rolls this way. Along the way, you make payments of $4 million, and an amount here to pay off the loan. So, in terms of rationalizing this problem, though, we're going to have to break the problem down into parts. Okay, I'm going to call this part right here, which is that first year, part 1. I'm going to call this part right here year 1 to year 3, part 2. And I'm going to call this final part from year 3 to year 5, part 3. Okay? So really, if we combine part 1, 2, and 3 together, we will have the total amount. So let's take a look at part 1 first. So effectively, what we're going to have is $10 million. It's going to sit for 1 year, and it's going to be earning or costing 4% compounded interest, and it's compounded annually. Okay. So what we want to ask ourselves is, what will the value be at year 1? That's the very first thing we need to ask ourselves. So, it's a lump sum payment, and it's going to stretch for 1 year. So we want to find out the future value. So by definition, we use the future value formula. Future value is the present value, 1 plus I to the n. The present value is $10 million. 1 plus I, which is 0.04, which is a 4% interest rate, to the power of n, and n is the number of compounds. So if we look at this, this is going to, if we'll check this, make sure that we do compounded annually, $4 million, yeah. So in this case, n is 1 year. Okay? If we do the math on that, then that will be $10,400,000. So what we're really saying there is that in year 1, at that point, there'll be $10,400,000 outstanding on that loan. Now, of course, it says we pay $4 million. So let's take $4 million off of that. That means the balance on that loan is really $6,400,000. Okay? So there's the balance on the loan, and that's important because that in balance there at year 1 is the beginning balance for part 2, which stretches from the beginning of year 1 to year 3. So let's take a look then. We need to be able to calculate part 2. So part 2 has that money, $6,400,000. We're looking for the future value of that. So it's the present value, 1 plus I to the n. So the present value at that date there is $6,400,000. 1 plus 0.04 to the power of n. It's year 1, year 2, year 3. 2 years to the power of 2. We do the math on that, and we will get the balance there will be $6,922,240. So that's how much that's going to be worth at year 3. So I'm going to write it down here, $6,922,240. Of course, we're paying $4 million on that, so we're going to subtract $4 million off this amount. That means the balance that we have there now is $2,922,240. Okay? So that's $2,922,240. That $2,922,240 is going to sit from year 3 to year 5. It's going to sit for 2 years, and we need to figure out how much is that going to be valued at year 5. So let's take that. So I call this part 3. Okay, part 3. So we got again FV equals PV 1 plus I to the n. So PV is 2,922,240. 1 plus 0.04 to the 2 years 2. So that comes to $3,160,694.78. So essentially, on that day, year 5, there'll be $3,160,694.78 owing. And because of that, in order to pay it off, we'd have to pay, so the final payment will be $3,160,694.78. And that's how that works. Okay, next I wanted to take a look at this problem here. If an investment can earn 8% compounded quarterly, what do we need to invest today in order to accumulate $20,000 in 3 year 3? Well, let's take a look at this again. I like using a number line or a timeline. So this is year 3. We need $20,000 now. So we're looking for the present value that we require there. And it's 8% compounded quarterly. So it's 8 divided by 4, that's 2% per quarter, which is 0.02. Okay, so now we need to ask ourselves, how many compounds do we have? So we need to look for n. Well, there's 4 quarters per year times 3 years, so that's 12. Okay, so that's our basic information. We're looking for the present value, so that's the future value, 1 plus I to the n. Plug the number in. Future value is 20,000. 1 plus 0.04 2 to the 12. You do the math on that, or to the minus 12, I should say. That should be minus. To the minus 12, and that's $15,769.86. So what we're really saying is that if we had $15,769.86 now, and put it in this savings vehicle earning 8%, compounded quarterly for 3 years, it would add up to $20,000 in 3 years. Next, we'll take a look at this one here. Okay. Q3A, payments of $500 are due in 1 year from today. $5,000 due 5 years from today are to be replaced by $30,000 payment in 3 years from today and a final payment in 4 years from today. Assuming the interest rate is 8% compound monthly, calculate the value of the missing payment. So let's take a look at drawing this out. This requires 2 number lines. Well, first of all, we'll look at our first stream. I'm going to call this stream 1. Okay? Stream 1. Payments of $500 due in 1 year. 1 year, $500. And another $5,000 in 5 years from today. Okay, so that's the first stream. It wants to be replaced by a $3,000 payment 3 years from today of $3,000 and a payment in 4 years of some mystery amount. So there's our mystery amount. Assuming the rate is 8% compounded monthly. Okay, so what we need to do is figure the value of the missing payment. So how do you go about doing this? Well, first of all, you need to calculate the focal date. The focal date, here's a simple way to remember the focal date. It's always the mystery date, okay? So the focal date will be year 4. Now, what difference does that make? Well, what we need to do is bring everything to that date. So what we're going to do is we're going to say, well, how much is $500 in year 1 worth on that 4th year? How much is the $5,000 in year 5 worth on that year? And how much is the $3,000 in the second stream worth on that year? So that's 3 sub-problems that we need to do. Okay, we need to do 3 sub-problems. And here's the basic concept. The first stream, the value of those amounts in the first stream, the 500 and 5,000, will be calculated using your math. And the value of the 3,000 will be calculated. The difference between the two is the mystery amount. Okay, so that's how that works. So let's go about solving this problem. First, I'll take a look at the stream 1 information. Okay, stream 1. Okay, stream 1. Now what we're going to do there is we're going to calculate the value of the $500 in year 4. That's essentially what we're doing. Okay, we're going to take that 500, bring it up to year 4. Now, how far away is that? Well, the time is really going from year 1 to year 4 is 3 years time. Okay, and it's 8% compounded monthly. So I then is 8% divided by 12, and that's that comes out to a decimal of 0.0066. Repeating. And n is the number, so it's 3 years times 12 per year. 12 compounds per year, so we're dealing with the number of compounds. That's 36. So there's our basic bit of information that we have to plug into the formula. So we're going to get the future value of this. We want to bring 500 up to here. So what is the future value? for future value is the present value, 1 plus I to the n. We'll plug those numbers in, so it's $500 is present, 1 plus 0.0066 to the power of n, and we calculate n to be 36. If you do the numbers on that, that will come to $635.10. What this is saying is that $500 that you started off with in year one is going to be worth $635 in year four. Okay, that's the first part of what we're doing. Now, I say we're working on stream one first. The other payment that was in stream one was the $5,000 that was paid in year five. So we're going to have to calculate value of the 5,000 in year five. So we got to bring it back. So the time, what we're going to do is bring it back 1 year. It has to come back 1 year. And again, the I is the same, so 0.0066. We've already calculated that. The N, it's 1 year times 12 compounds a year, so that's 12. So, okay, let's plug that into the formula. So in this case, we're looking for the present value. So PV equals FV 1 plus I to the minus n. We take the future value amount as 5,000, 1 plus 0.0066 to the power of minus n. We'll calculate n to be 12. So there we do the math on that number, and that comes to $4,616.84. Okay. So essentially, what that 4,000 is the value of the 5,000 5 years brought back. So if we added these two together, if we take two of these, this one and this one, we'll know the value of the stream one on year four. Okay? So at year four, so if we add two of those up, that comes to $5,251.94. Okay. So that's the stream one. Now let's take a look at stream two. I'm going to go over here and do this, make sure you can see it. So this is stream two. So stream two is really looking at $3,000. So it's $3,000 ahead 1 year. It's $3,000 was paid in year three. So let's bring it ahead 1 year. So we're looking at n equals 1 year times 12 compounds, so the n is 12. I equals 0.0066. So the future value then of that is PV 1 plus I to the n. So that's the same as 3,000. 1 plus 0.0066 to the 12th. And that comes to $3,248.97. So what we're saying here, this 3,248.97 is really the value of that $3,000 in the second stream at year four. So what we got is the value of the first stream is worth $5,251.94 at year four. The value of the second stream that we know of is $3,248. So if we were to take 5,251.94, which was the value of the first stream, subtract what we know the value of the second stream to be, 3,248.97, the difference between the two must be that last payment. So that will be $2,002.97. So effectively, the answer to the problem is that last payment at year four should be $2,002.97 in order to settle the debt.